On a plane, a line equation is given and the plane equation has two variables alpha and beta. We need to get the values of alpha and beta such that this line is on the plane. Now if you look at this diagrammatically, on a plane whose equation is known to us, let's call this plane as pi. A line exists whose line equation is L. Now when do we say a line is on the plane? Yes, every point on the line will be a point on the plane. Now if you observe the equation of the line, clearly this point P, which is having 2, 1 and minus 2, is a point on the line. Then as the line itself is on the plane, even the point P2, 1 and minus 2 should also be on the plane, right? Not only this, there will be a normal to the plane which is also perpendicular to the given line. So we got two conditions. One is the point P lies on the plane and another one is the normal of the plane will also be a normal to the given line. Let's use each of them to get the values of alpha and beta. What is equation of the plane given? The equation of the plane is, that is pi is x plus 3y minus alpha into z plus beta equal to 0. So what are the drs of normal of plane? The drs of normal of the plane pi will be 1, 3 minus alpha. This is a very important observation that we use. Now, when do we say this line lies on the plane? The line L given by x minus 2 by 3 equal to y minus 1 by minus 5 equal to z plus 2 by 2 lies on the given plane pi. So what do we mean by that? Every point on the line is also a point on the plane. So shall we say 2, 1 minus 2 is on the plane pi. Now when do we say this is a point lying on the plane? Yes, this point should satisfy the given plane equation. That means 2 plus 3 into 1 minus alpha into minus 2 plus beta equal to 0. So this would lead us to an equation in alpha and beta which is 2 alpha plus beta is equal to minus 5. Let's treat this as an equation 2. Now how do we create another equation in terms of alpha and beta? Two variables are there, so this equation is not sufficient. Yes, for that I am using the condition that normal to the plane pi is also perpendicular to the line L, and we know the drs of normal of the plane and we know the drs of the given line equation. So when do we say this normal of the plane is perpendicular to the given line? Yes, 3 times 1 plus minus 5 times 3 plus 2 times minus alpha is equal to 0. So here there is no beta involved. Directly we will get the value of alpha. Let us say 3 minus 15 minus 2 alpha equal to 0, or shall we say alpha equal to minus 6. Now once we have the value of alpha, let's carry this value of alpha and substitute in equation 3. We get 2 times minus 6 plus beta is equal to minus 5. Now what is beta value from here? Yes, it is minus 5 plus 12, which is 7. So we got the value of beta and we know the value of alpha. So how will be the values of alpha and beta? Alpha being minus 6 and beta being 7. Which option it is satisfying? The option D, which says alpha and beta are the values minus 6 and 7, right?